Okay, now I'll put you on the cooker, don't break the glass. Right, what we're doing now is we're working out the fixing for the Z-axis onto the X-axis. Get right in a minute. And what I'm going to try and do is have two places. That's exaggerated, obviously. One sort of like down here for printed circuit board work. Not that close, obviously, but you know, within a sort of like there-ish. And then, if for any reason I've got to do anything thicker, I can bring it up to there. Now I know what you're all thinking. Because I have a lot of weight this way, isn't it? Now I got that sorted, don't worry. We'll come to that later. Right, the way I'm doing it, well, the way I'm going to try and do it, is I'm going to have two pieces of plywood in there like that. And no, they're not going to just stay like that. And then a piece of plywood is glued along there. A, to hold those in the correct position, and also to bring the Z-axis out to the same level as the front of the carrier. Right? And how are we going to do that? Oh well, I thought I'd use some clothes pegs. I'll bring you a bit closer and then you can watch me make a fool of myself. That's wrong way. I'll get this zooming right one day. I think that's... you can see both there. Okay. Right, so what we're going to do is we're going to put some liquid weld onto each of these, and then I'm going to peg the, whoops, get in there, peg that in position like that till the glue goes off. Not bad, is it? You would leave it like that? It won't work. Oh, alright. Okay, so we'll do it this way then, yeah? Okay, right. And then the other one, obviously, will come up and glue, whoops daisy, like that. And they'll fall out like that. Right, until the glue goes off, I'm going to leave them in the carrier until the glue goes off. And no, I'm not relying totally on the glue. I should be drilling and screwing it later. This is just to get it in a position. It saves measuring and, you know, trying to work everything out that way. Right, this is where I get sticky hands. Or sticky fingers. Right, and then it's about the, well, it will be the width of the carriage within a few watt names. But there's the first one. Try and get them level if you can, because it'll all help in the long run. Okay, make sure that that's sitting down onto the carriage bit. So when that comes forward, yep, that's right. Okay, we're going to let that go off. and we'll come back to that in a minute. Okay, one thing I got to point out to you from the last video, the screw thingy in the bottom of here. Well, you'll notice that it's a lot longer than before. Right, now what I did was I still got the cut-off screws that I showed you, but it's cut a bit shorter. But I was having trouble with it staying on the end of the thing without threading back down into the bearing. So what I've done is I've screwed, you see that? I can't tell with this screen. I'll assume you can see that. But I put another screw all the way in and locked the two together so that they can't unscrew. And as you can see, that's going to look quite nifty there. Now, just need to turn it around the wrong way. Yeah, you can see that. Okay. The motor mount is either going to be some blocks of MDF or pillars. I'd like to go with MDF because I can basically trap it in position. But again, pillars would be good as well. The reason I'm not very keen on pillars is because of this. I mean, I'm exaggerating it, but it's to because I don't like the possibility of that happening. So I think a block of MDF or the like, just to hold it in position. I mean, just on the end here even. I think that will do nicely. I still haven't found anything to put in here to stop the MDF wearing away while this is pushing against it. So I may find another gear or something that I can put on this side to basically on this side, basically to sandwich this cog between the drive motor and the pulley, thereby not putting so much pressure on the MDF here and it wearing away. Still haven't quite figured that little bit out yet, but I'll get there in the end. Right, I'll let that go off and I'll come back when I'm ready to do the next bit. Okay. I'll try not to be different. Now then, these have gone off nice and tight. I'm now going to show you what we're going to do with these. What I've done is I've marked two places on here where I want to fit this, right? Now, that position there, oops, is going to be, and you can't really see that, so hang on, let me tip you up a bit. Ah, no, take out a bit, that'll be even better. Oops, I always go the wrong way. Right, let's try that. I'll bring you back in again in a minute. Right, now that is one position, okay. Now for printed circuit boards, the drill's going to be down here, the sled's going to be here, and there's going to be a lot of Dremel sticking out down the bottom. So for printed circuit board work, I want to be able to bring her down to there, so that most of the Dremel is supported here, and I can drill my printed cut my printed circuit boards no problem at all. Okay, because the Dremel will be supported about this position, I suppose. So it won't be sort of like on the end, as it were. But for taller work, by taller work I have no idea what I mean, but I want the ability to be able to do it if I need to. Right, so we're going to use the top line, and we're going to place it central. How do you define central? Well, you find out how wide the timbers you're going to use. So this is a fraction under 4 inches, or exactly 100 millimeters, or 15 light years. Right, so we're going to mark that at 50 mil as the centre. Okay. Now, when I'm using something big like this, what I tend to do is, if I'm drawing a line like that, and I find a centre like that, that's exaggerated, but it shows me exactly where the centre is, rather than a little line like that. So that's given me my centre. So now I need to find the centre of this. Same thing. How wide is it? 3 inches, inch and a half. And by marking the top like that in the middle, means that I can line the two up and it'll be spot on. Now I can either glue and screw these, okay, so that's fixed, and make another one down here and glue and screw that one, or I can just screw it and then move that one down to there. Now preferably I want to glue and screw it, because predominantly this will be my position. If I need to bring the Z-axis up for doing a bigger job, I think they're going to be rarer than doing printed circuit boards. So I think I'll glue and screw that in that position, and then if I need another one there, I've got this one as a pattern and I can make another one there when the need arises, but the ability is there. So before we get the liquid welder out, we're going to drill a hole, and I'm prepared this time. I've got my screws. Right, now this hole is going to be tight for the screws. And yes, I am doing it on the Y table, because I'm doing it over a support. See? If I was doing it there, yes, you could moan, complain and say, "Oi, you're doing it wrong." Have I ever done anything right? Well, there's a good question, isn't it? Right. Okay. Now then. I'm not measuring this because the measurements on this would be arbitrary, because it will depend on your carriage, it will depend on the size of your Z-axis when you come to do it. The only reason mine is this size is the way I'm mounting my motor. So you might have a different way of mounting your motor, which would make this smaller. You may have the parallel bars for your sled to run up and down, shorter because you can't find longer ones, etc, etc. So all I'm doing here is just sticking one hole in the middle. Well, I don't look in the middle, Raymond. Oh, that's better. Yep. Right. Okay. Now I'm not going to go charging in with great big screws. Give it a little mix. Okay. I'll just clean these up. Now, I don't know if any of you are actually building as you're watching, but if you are, I hope you're thoroughly enjoying the project. And if you're trying to get all the stuff up together to do the project, I hope you're doing well. Okay, liquid welder. Right. Just press that down there. Spread it all out. Spread it all over. And try and get the edge of the wood as close to on the line, on the edge of the line as possible. That's your straight bit. A little bit of pressure for a while, and then we can put the screws in. I mean, you could leave this to go off before you put the screws in if you wanted to. I know I don't sound it, but I'm just as excited getting to this stage to actually see the the Z-axis in position on its own, so to speak. I did say earlier that I've got something in mind for the top support, and to that end I've gone ahead, measured up a piece of odd MDF that I got left, and I've measured up and drilled two fixing holes, one there, one set there, and one set there. And what's going to be going in between, ta-da! That long rod I had that I couldn't work out where I'm going to put it. What I'm going to do is have that in, well, that's exaggerated obviously, but it will be in the MDF like that. You see that? About, I don't know, halfway. Just mainly support more than anything else. And then coming off the back, I'm going to have something sliding along there. I may also put something up here to go down the back, so if there's a catastrophic failure of some kind, it'll just drop down onto here and it'll stay put. Well, that's the idea anyway. Whether it will come to fruition is another matter. I know this screwdriver is too small, but I want to get it through the plywood. There we go. Before I start screwing. Right, here we go. Right. I think it did. That one twisted a bit. And we do the second one. I'm not worried about these being single screws on these bits because, oops daisy, that didn't look very good, did it? Because I thought that were screwed in. And you're all now having a laugh. I knew they were too short. How too short are they? You twang Crayman. And there was me, chuffed to bits because I got them all ready. They're a good half again too short. Right, I'm not going to bore you while I'm looking for screws, so I'll turn you off and I'll bring you back when I found them. Alright.